Ever wondered what lies beneath the surface of our planet? We walk upon the skin of a world of hidden wonders, where rock flows like liquid and the very heart of our world beats with the pulse of creation. Today, we're diving deep into the Earth's layers to uncover the mysteries hidden beneath our feet. Our journey will take us from the familiar crust, our planetary home, down through layers with exotic names like the mantle, the outer core, and finally to the inner core. Each layer has its own story to tell, a story written in stone and fire, helping us understand how our planet came to be and how it continues to evolve. So buckle up, fellow explorers, as we embark on this grand adventure into the heart of our world. Let's begin our descent. Here we stand on what we call solid ground, but the Earth's crust is but a thin veneer compared to the vastness within. Imagine, if you will, an apple. That thin skin of the apple, that's the relative thickness of the Earth's crust compared to the entire planet. The crust is a mosaic of constantly shifting tectonic plates, gigantic slabs of rock that grind against each other, creating mountains, valleys, and earthquakes. It's a dynamic layer shaped by both the immense heat from within the Earth and the erosive forces of wind, water, and ice on the surface. The crust is further divided into two types: oceanic crust, thinner and denser, forming the ocean floors, and continental crust, thicker and less dense, making up our continents. This difference in density plays a crucial role in the dance of the continents, a slow, graceful ballet we call plate tectonics. We live our lives on this thin, fragile crust, this island in the vastness of space. So let's dig deeper, shall we? Let's delve into the hot, molten layer beneath the crust, the layer known as the mantle. Beneath the crust, extending down for nearly 2,900 kilometers, lies the mantle, a realm of intense heat and pressure. Here, temperatures can soar to over 3,700 degrees Celsius, hot enough to melt rock into a viscous, flowing substance called magma. The mantle is not a uniform sea of molten rock, however. It's composed of different layers, each with its own unique properties. The upper mantle, just below the crust, is relatively cool and brittle. But as we descend deeper, the mantle becomes hotter and more fluid, behaving like a very viscous liquid over geological timescales. This fluidity is key to understanding plate tectonics. The mantle's slow, churning convection currents, driven by heat from the Earth's core, drag the tectonic plates along with them like rafts on a slow-moving river. The mantle is also responsible for volcanic activity. Magma generated in the mantle rises through cracks in the crust, erupting onto the surface as lava, creating new land and shaping our planet's ever-changing face. Volcanic eruptions, while destructive, also bring up nutrients from the mantle, enriching the soil and supporting life. The mantle is a reminder that our planet is not static, but a dynamic system, constantly evolving and changing. And as we delve deeper, we encounter even more extreme conditions, even more astonishing phenomena. Prepare yourselves, explorers, for we are now entering a truly alien realm, a place where temperatures soar to over 5,000 degrees Celsius, and the pressure is so great it would crush a human in an instant. This is the outer core, a sphere of molten iron and nickel, a swirling ocean of liquid metal over 2,000 kilometers thick. This churning motion generates Earth's magnetic field, protecting us from harmful solar radiation. Without the outer core, life as we know it would not be possible. The magnetic field deflects charged particles from the sun, preventing them from stripping away our atmosphere. It's a silent guardian, essential for life. But our journey is not over yet. Let's venture deeper still to the very heart of our planet, to the mysterious inner core. And here we are, at the very center of our planet, a place of unimaginable pressure and heat, a place that has captivated the human imagination for centuries. This is the inner core, a solid sphere of iron and nickel, over 1,200 kilometers in diameter, a ball of super-hot, incredibly dense metal. The pressure here is more than 3.5 million times the pressure at the surface of the Earth, a pressure so great that it forces the iron and nickel atoms to pack together so tightly that they can no longer flow like a liquid, even though the temperature is estimated to be over 5,200 degrees Celsius, hotter than the surface of the sun. Scientists believe that the inner core is slowly growing as the Earth cools. with molten iron from the outer core solidifying onto its surface. This process of solidification releases heat, which helps drive the convection currents in the outer core, which in turn generate the Earth's magnetic field. Recent studies suggest that the inner core might not be a uniform sphere of iron and nickel, as previously thought. There might be layers within the inner core, each with slightly different compositions and properties. Some scientists even speculate that the very center of the inner core might be composed of a giant single crystal of iron, a diamond planet within a planet. The inner core is a stark reminder of the immense power and mystery that lie hidden beneath our feet. It is a place of extremes, a place that challenges our understanding of physics and chemistry, a place that continues to inspire awe and wonder. Now let's step back and take a broader view, looking not at a single layer, but at a zone that encompasses both the crust and the uppermost part of the mantle. This is the lithosphere, Earth's rigid outer shell, broken into a mosaic of tectonic plates that float on the semi-fluid asthenosphere beneath. Imagine, if you will, a cracked eggshell, its pieces constantly shifting and jostling against each other. That's a simplified view of Earth's lithosphere, a dynamic system that shapes our planet's surface. The lithosphere is where the Earth's internal heat engine and the external forces of erosion and weathering interact. It's where mountains rise and oceans form, where volcanoes erupt and earthquakes shake the ground. The lithosphere is divided into about a dozen major tectonic plates, each moving slowly but relentlessly, driven by the convection currents in the mantle. These plates collide, diverge, and slide past each other, creating the dramatic features of our planet's surface. At convergent plate boundaries where plates collide, mountains are pushed upwards, volcanoes erupt, and earthquakes release pent-up energy. At divergent plate boundaries where plates move apart, magma from the mantle rises to the surface, creating new crust and widening ocean basins. The lithosphere is a testament to the interconnectedness of Earth's systems, a dynamic zone where the internal heat engine and the external forces of nature converge, shaping the planet we call home. And there you have it, the incredible layers of the Earth that make our planet so unique. From the crust we walk on to the fiery depths of the inner core, each layer plays a crucial role in Earth's structure and dynamics. We've journeyed from the familiar surface of our planet to the depths of its core, encountering unimaginable pressures and temperatures, witnessing the forces that shape our world. And yet, we've only just scratched the surface. There's so much more to learn, so much more to explore. Thanks for joining us on this journey to the center of the Earth. Keep looking up, keep asking questions, and never stop exploring the wonders of our universe, both near and far.